All right, here we go, MAP4C, lesson 1.2 and 1.3, part 2. We just sort of finished the morals of the story as far as finding trig ratios of obtuse angles. And I think we're ready to try some examples, homework type stuff. Is the stated trig ratio positive or negative? And those are basically the rules that we just talked about, right? We said for an obtuse angle, the sine is positive, but the cosine and the tangent are negative. So let's just go through these. There's an obtuse angle, but it's a sine, so that's positive. Cos of an obtuse angle, well, that's going to be negative, right? And you can check it with your calculator, but it is. Acute angles, when I take trig ratios of acute angles, it's always positive. So that one's a positive, that one's a positive, that one's a positive. The tan of 168, well, the tan of an obtuse angle is negative. That's it. That's all we're expected to do there. An example 2, how many solutions does each equation have? This was one of the morals to our story, is that the sine of A equals blah has 2 solutions. The other 2, it didn't say anything, so we'll have to think about what that might mean. But the sine of A equals blah has 2 solutions, so there's 2 solutions. And it says, is angle A obtuse or acute? And remember, when it's sine A equals that, there's one of each. There's an acute angle that the calculator gives us, and then we go 180 minus that to get the obtuse angle. So there's 2 solutions, one's acute and one's obtuse. Cos of A equals negative 0.34. Remember, when the cos is negative, then there's only going to be one solution, and it's obtuse, right? Because when the cos is negative, the answer is obtuse. Same thing for tan. So this one's only got one solution, and it's obtuse. Example 3, we're asked to find these solutions. So here, sine of A equals 0.23. Well, we're just going to use our calculator, do the inverse sine. Inverse sine is 0.23, and we jam that into a calculator, and we get 13 degrees or so. So that's the one acute angle. How do we get the obtuse angle? Well, 180 minus that. What's that? 167. Over here, if we do the inverse cos of this, which that looks a bit strange having a negative number in there, but it works out just fine. The calculator gives you a number 109, and that's an obtuse angle, right? Where this sort of shows up is this will show up sometimes in the sine law and the cos law, and that's what we're going to do the next couple of days, where we'll have to deal with obtuse angles, and we'll see where that shows up then. But we had to spend the day today sort of figuring out what it means for trig ratios to be negative, and what it means when the sine, this equation right here, has 2 solutions. In grade 10 and 11, only one. This is a weird one. Okay, when I do the inverse tan of this one, the calculator, kind of like in the sine one here, it tricks us a little bit. You do this and you get negative 77 degrees. How can that possibly be negative 77 degrees? And ultimately what it does, it comes back to that grid, right? We said, well, the obtuse angles are rotated this way, but that can't be. That's not negative 77. And negative 77 degrees is actually this way. Now, when would we ever use that? We are never going to use that. In other branches of mathematics, they might. But it says that's 77, and your calculator's giving you that angle. We don't want that angle. We want this obtuse angle. We want the one where that's 77. So again, we're just going to go 180, subtract 77, and get 103, and that's A. We'll hardly ever see, because there's no tan law, we'll hardly ever see, except for today, this tangent business. All right, what's last? What's last is we want to do one of the ones from homework together. So this is from your textbook, and we want to determine the indicated trig ratio in each triangle. So it says there's the points here, and then we're going to do A, which is point P. It makes a angle with the positive x-axis. There's the triangle there. And we can see there's angle A, like we're used to. This is -4 there, that's 3. And if we want to find the trig ratio, notice it doesn't ask us to find A. Of course we could. Of course we could. But it doesn't ask us. So determine the indicated trig ratio in each triangle. Well, we want to find the sine of A. That's the opposite side. The hypotenuse we don't have, so we're going to have to find it. Good old Pythagorean theorem. Nine plus 16 is 25. Square root of that, r is 5. Oops. 5. And then the sine of A is opposite over hypotenuse, 3/5, and it's positive. Even though the angle is obtuse, the sine is positive. Notice if we were going to find the cosine or the tangent, both of those would be negative. Cosine and tangent of an obtuse angle is negative, the sine's positive. All right, that's it. The homework is little bits and pieces from 2 sections in the textbook, but you should be able to fly through it. Most of the learning today happened in that investigation and in the little lesson that we had today. That's it.